What if Earth began to drift toward a black hole? At first, the night sky would look calm, but slowly, stars would start to stretch and bend like reflections in rippling water. The moon's orbit would twist out of balance, oceans would rise in strange patterns, and the pull of gravity would grow stronger every second. Soon, light itself would bend toward the darkness, as if the universe was being swallowed. But what would really happen if our planet fell into a black hole? Could anything or anyone survive that journey? This is the story of what scientists call the most extreme event in the universe, where space, time, and matter break all the rules we know. If Earth ever started falling toward a black hole, it would be a journey with no return. Black holes are not like stars or planets. They are regions of space where gravity is so strong that nothing, not even light, can escape. Imagine a massive object billions of times heavier than our sun, compressed into a point smaller than a city. That's what a black hole really is, a place where the laws of physics stop making sense. At first, everything would look normal. From far away, the black hole would just seem like a dark spot surrounded by glowing rings of gas and dust. But as Earth got closer, the sun's light would start to bend strangely. The stars behind us would begin to stretch, forming long trails of light called gravitational lensing. Even though it might look beautiful, it would be the first sign that space itself was being twisted by the black hole's pull. The first major effect we'd feel would be on Earth's orbit. The black hole's gravity would slowly overpower the sun's hold on our planet. Earth would drift away from its normal orbit and start falling through space toward the dark center. Temperatures would drop quickly as we moved away from the sun. The oceans would freeze, the atmosphere would collapse, and life as we know it would end before the black hole even came close. But let's imagine Earth somehow stayed intact. As we approach the black hole, we would reach a zone called the event horizon. This is the point of no return. Once anything crosses this line, it can never come back. Not even light can escape beyond it. The event horizon isn't a solid surface, but an invisible boundary in space where gravity becomes infinite. Now, here's where things get truly strange. The closer we move toward the event horizon, the more time itself would begin to slow down. To an outside observer watching from a distance, it would look like Earth was moving slower and slower, almost frozen in time. From our point of view on the planet, everything would seem normal, but clocks in space would tick faster and faster compared to ours. This effect is known as gravitational time dilation, one of Einstein's most mind-bending discoveries. As Earth crossed the event horizon, something horrifying would begin to happen. Spaghettification. Because gravity is stronger on one side of Earth than the other, the difference in pull would stretch the planet like a piece of dough. Mountains, oceans, and continents would be ripped apart. The planet's crust would melt, the core would explode outward, and eventually, even atoms would be torn to pieces. For humans, the experience would be instant. You wouldn't even have time to feel pain. Your body would be stretched thinner than atoms before your brain could process what's happening. The black hole's gravity doesn't crush things the way we imagine. It stretches them into long, thin streams of matter. And once Earth is fully pulled in, everything that ever existed on our planet, every person, every building, every memory, would disappear into darkness. Inside the black hole, there's no clear destination. Space and time no longer behave the way we understand them. The moment Earth crosses the event horizon, it stops being part of our universe as we know it. Nothing can escape, not light, not information. To the outside world, Earth would seem frozen forever on the edge of the black hole, slowly fading as light from it stretches into invisible wavelengths. But from inside, the story continues, though no one truly knows how. Scientists believe that at the center of a black hole lies a place called the singularity. This is a point of infinite density where all matter is crushed into zero volume. Every law of physics breaks down there. Gravity is so powerful that space and time are twisted into one another. If Earth somehow survived long enough to reach this point, every atom would be squeezed into something unimaginably small. The concept of planet, or even matter, would no longer exist. However, some theories suggest that the singularity might not be the end. In fact, some scientists think black holes could be connected to other parts of the universe, or even other universes. But this idea comes from the concept of wormholes, tunnels in space-time that might link distant points together. If this were true, Earth's remains could be transported somewhere else entirely, perhaps emerging in another universe with completely different laws of physics. It's a fascinating idea, but for now, it remains pure theory. Meanwhile, something even more interesting happens just outside the event horizon. Not everything that gets near a black hole disappears instantly. Some matter swirls around it first, forming what's called an accretion disk. This disk glows brighter than any star because it's made of gas and dust, heated to millions of degrees by friction and gravity. If Earth fell in, it would likely be torn apart and become part of this fiery ring. From far away, the black hole would look like a glowing halo, a deadly, beautiful light marking the death of our planet. Even stranger, black holes aren't completely black. In 1974, physicist Stephen Hawking discovered something called Hawking radiation. It means black holes slowly lose energy over time, releasing tiny particles into space. This process is extremely slow, but it suggests that black holes can eventually evaporate. For a supermassive black hole, that would take trillions of years, far longer than the age of our universe. But when it finally happens, all the energy and information trapped inside would be released in one final burst. So, in a way, Earth wouldn't be gone forever. Its atoms, energy, and even the faint imprint of everything that ever happened here could someday re-emerge when the black hole dies. It's almost poetic. The idea that even in destruction, nothing is truly lost. Everything that falls into a black hole becomes part of the fabric of the universe itself. If we step back and think about it, the story of Earth falling into a black hole is not just about destruction, it's about transformation. Every particle, every bit of energy that once made up our world would still exist, just in a new form. In the universe, nothing is ever truly gone. It only changes shape from one kind of energy to another. But let's imagine, just for a moment, that a future civilization far more advanced than ours could somehow watch this happen from a safe distance. Their telescopes would capture the last light from Earth stretching and fading as the planet spirals toward the black hole. They would see the colors shift toward red, a process called redshift, caused by gravity pulling the light waves longer and longer. To them, Earth would seem to slow down, frozen forever just before crossing the event horizon, a haunting image of a world paused in time. And yet from our point of view, inside the falling planet, everything would feel normal. Time would keep moving, seconds would still pass, but the rest of the universe outside would appear to speed up infinitely. Stars would flash by, galaxies would seem to age in seconds, and the universe itself would look like it's ending right before our eyes. That's how powerful time dilation becomes near a black hole. It doesn't just bend space, it distorts the very flow of time. The deeper we fall, the stranger the laws of nature become. The black hole's core, the singularity, is a place where space and time switch roles. Instead of moving through space toward a point in time, everything moves through time toward a point in space. That means reaching the singularity isn't like traveling somewhere, it's like reaching the end of time itself. But here's where modern science adds a twist. Some physicists believe that the singularity might not be a single point of death. Instead, it could be a doorway. If that's true, the inside of a black hole might lead to what's called a white hole, the opposite of a black hole. A white hole would spit out matter and energy instead of swallowing it. This could mean that what falls into one black hole might someday emerge from another, possibly in a completely different part of the cosmos. Of course, no one has ever seen a white hole, and there's no proof that such a thing exists. These are ideas that come from the math of Einstein's equations and the limits of human imagination, but they remind us of something powerful, that the universe is far stranger, more complex, and more mysterious than we can easily understand. If Earth ever truly fell into a black hole, humanity would be gone. But the atoms that once formed us would continue their journey through time and space. They might become part of a star, a galaxy, or even a new world billions of years from now. In the grand scale of the universe, death and creation are often the same thing. One endless cycle of energy, matter, and mystery. And that's what makes black holes both terrifying and beautiful. They show us the limits of science, the power of gravity, and the wonder of existence itself. Because in a universe where even light can vanish into darkness, the fact that we can ask these questions and seek these answers is proof that our curiosity might just be stronger than gravity. If you enjoyed exploring the mysteries of space and time, make sure to subscribe for more mind-bending science stories. There's so much more waiting beyond the stars, and together, we'll keep discovering what's out there.